First of all, thank you very much for this idea of the webinars. I fully support. There is an opportunity to increase connection and understanding of technologies available for different markets. So, okay, my name is David Castrillo, and I'm working for Hamamatsu office in Spain for a bit more of 25 years now. So if I want to introduce in a short way Hamamatsu, I should say Hamamatsu is a Japanese company. It was created in 1953. It's a company that grows organically, so it means we are not buying business or selling business. We do all around developing photonics technologies that need our customers. We have a very wide range of products. And if I have to define the company, what is the value that we provide to our customers is reliability of the products. If we see the distribution of the offices around the world, I should say that Hamamatsu decided to have own offices like this one in Spain because we need to create a very strong and fluid bond between the customers and the Japanese engineers, because our aim is to develop the detector that is needed for the next application. It means today we work on the detectors that people want to use in the future, in let's say 3-5 years. So we have these direct offices belonging to the Japanese company. I don't want to go to the vast range of products because it is too much. So I prefer to concentrate on the market segment. So here we see in these 3 horizontal lines. In the bottom one is our business based on optical sensors. It means we sell a lot in medical or automotive or other industries, but most of the customers need to work with electronics or need to create the application by themselves. We provide just the sensor. In the middle part, this is when we have this food manufacturing and the other 3 segments. We are delivering not only the sensor, but also the electronics and sometimes the optics. This is what we call the model. So it is not the solution, but it is closer to the solution. And most of our customers need to adapt the software or ask for some modification. And then on the upper part is when we have some kind of finished products that goes mainly to university or in the semiconductor industry. So here in this presentation, I concentrate in this food. So it means we deliver here mainly models, sensors with some electronics. So one of the first things that we might think in the food industry is to see inside, and because of this need, there is all the X-ray applications developed. So it's very relatively easy to see needles, but also bones or glasses. The X-ray is based on absorption, so it differentiates different densities, but also it takes care of the different thickness of the sample. And because of that, we also have X-ray cameras working in 2 energies. With these 2 energies, it is easier way to detect different contaminants, so different, like here, like the shell in the oyster. It's easier to detect by this double energy detection. Here I have to say that we not only deliver the camera, but also deliver algorithms to improve calibration, linearization, and many aspects to improve detectability. So by the use of X-ray, it's clear we can detect foreign objects inside the food, but also some abnormalities. But like in this onion that we see a boot inside, it's only the way to detect by X-ray, or from the peripheries, also some damage of the food. But of course, X-ray, it's very powerful and very good technology, but needs some safety regulation. So you need to have a certificate or trust with an instrument manufacturer that confirms there is a safety and has all the paperwork. So there are also other technologies that has not this barrier of the X-ray. So one of them is this infrared technology. Here we can use LEDs in even above 1 micron. There are LEDs or lamps to make illumination, and then with the cameras to see some defects. Here on the left side, we can see a defect that in the visible cannot be seen, but in the infrared we can clearly see. Why? This is not by density, this is by, as our colleagues already explained, by change of the spectrum. Here we see the change of the spectrum of the apple after 3 hours dropping. This is the effect of the shock. So we can monitor the spectrum change and see this defect. For this application, we developed quite a number of low-cost sensors, visible near infrared and more in the infrared. And it can be used not only for this, but also to detect the Brix value, that is a value that correlates with the sweetness of the fruit. This is we target in a kind of a consumer or product at the end. So we are targeting quite low-cost solutions for this. We don't want to forget that with the infrared, some materials are transparent. So here we can inspect the packaging of these candies because this packaging is transparent in the infrared. So we can also see through this material and other material. When we talk about security, I remember it was 10 years ago, these scandals in China because of the milk contamination for babies, or also some news we got that even they were producing plastic rice in China. This invisible can be difficultly seen one from the other, the fake product from the real product, but in the infrared it can be very easy. And for this we develop very, very compact and low cost sensors that go for this kind of application. In fact, if we see a sorting machine, this is kind of a typical sorting machine. This is the contamination of visible detectors that can be used, for example, to detect the color, and infrared detectors to detect foreign matter, like here stones, in this case of rice. Because we have cameras, I can show you 2 examples. One is in the coffee beans and stones on the left side. It is difficult to discriminate, but on the right side we can see very clear the 2 stones among the coffee. Also with the rice here, maybe the photo has too poor resolution, but here I increase I did a copy of the image on the right, and we also see the rice and the stones, the white stones, we can clearly see in infrared. So there are many applications like that. Then I also remember it was I think 9 years ago, we had in Japan this problem with the tsunami and the Fukushima power plant. And the company needed to develop also a kind of model for radioactive detection. We used to make them to map the land by wearing it with some car, but also we made some module that we used to inspect food radiation in rice bag or also in fish. It was also to keep safety. And applications, there are many others. So recently I heard that in Japan, someone was talking about a freshness sensor by using a lifetime measurement, but this is one thing that we still don't see in the market. What is, well, at least by myself, that applications are growing and growing constantly. So if you are thinking on an application or you want to collaborate or have some idea, you can contact me and we can discuss together what we can do. Thank you very much.
Okay, thank you, David. Thank you very much also for the clarity. The examples were very clear. And let's go with the questions for you. Those of you who have questions, you can do it through the chat. First one from Fernando Maya. David, thank you for your presentation. Where do you apply the X-ray? Is the ionizing energy an issue?
Well, yeah. Usually there is a lot of discussion on this topic, and if you check what is the government statements, usually X-ray is not an issue, but most of the consumers are afraid, especially when X-ray is applied to fruit or also to drugs or medicines. So what I will say is, we usually from our side we supply the product that our customer needs, and what we will recommend the customers is to check what is the law in a specific country, because it can change from one country to the other, and also what is the perception from the consumer, because maybe some consumer, they don't want to get food or some food that can be inspected. But from the safety, as far as I know, there are, for this level of ionization, there is absolutely no problem.
Okay, we have now five more questions, and we will stop there because time is over. First one, Tolo from MS Technologies. Hello, David. Do you have experience with quality control of corks for bottles with X-ray camera system?
Yeah, we have experience. Yeah, we have experience. Not direct experience, but experience through some partners. Because as I said, we usually deliver modules. So when there is application, like you say here in bottles, we need to rely with a partner. We have to work together, do some tests at our site, and also share with Japan. And this is a kind of partner project. But yes, yeah, some application, yeah.
Okay, next question. Have you developed new sensors for smart packaging?
Well, usually a smart packaging uses a kind of ink or a kind of sensor in a kind of label or this. So if you mean the sensor inside the packaging, I cannot remember. If you see sensor from the outside to check the package, yes, for sure. But inside the package, no. Usually, I don't have the experience inside the package. Yeah.
Okay. The next question comes from Colin Burham. He asks, why is X-ray limited to 2 spectral levels? Are more levels possible to obtain greater information?
Yeah, absolutely.
Sorry.
Di aprofito e truco ara, ja.
We are having some issues with micro.
No.
A veure, jo...
Yeah.
Bueno, què tal?
Wait a second, David.
Yeah. I think now, yeah. Okay, yeah. I think dual energy is the standard solution today. We are working with multi-energy. We have a couple of technologies to allow multi-energy, and multi-energy is probably the solution in the future to go to more more data. Up to now, it was quite expensive. We developed at the end of last year a new technology that probably becomes much cheaper, and we are now testing. So if there is some application that especially needs multi-energy, we are ready to test the new technologies that we are developing. But they exist and they are available, yeah. Hello?
Hello, David. Wait a minute, because I silenced everyone, I muted everyone, and I also muted Sergio, and I'm looking for him.
Okay, I'm here. Sorry. There is another user who's asking for you to show your last slide because he's curious about the role of the PMT. Okay.
Yeah. Yeah, it means you do a flash light, and then you take a kind of fluorescence decay. So according to the decay, of course, there is some algorithm or some know-how to correlate this with the freshness of the. In this case, it looks a kiwi. Mm-hmm. So it will be. Of course, does it depend on the temperature of the kiwi? So is there other effects that can make some trouble in the measurement? This is more in the application side. So it means what we usually do is we develop or we adapt the detector based on our customer requirements, and usually the knowledge of the whole application is at the customer. This is also the point that we want to connect also with research centers, with the academia, with some engineering company, in order to co-partner or co-work together and try to answer all the new questions that come.
Okay, thank you, David. And there are 3 more questions, but the time is over. Then we have 3 more questions from Jacek Kulakowski, Ferran, and Efu Yadosa. And what we are doing, if you agree, is to share these questions with you through email tomorrow or in 2 days for you to answer them with more time. Okay?
Okay, perfect. Thank you very much.
Thank you, David.